Now I did ended up having to change both polarizers on this LCD because the other one was also bad too, as it started delaminating and it had a big burnt spot when I put the first one on there, I noticed. So I ended up doing both sides, and you do have to match the right degree on the polarizer to the LCD, which I went ahead and tested to find the correct one and change both sides. So here you go. Hopefully it'll still work. I do gotta get some of that glue because I had to glue these back on. But I did work out all the bubbles and stuff like that because this is the one with the adhesive on it. So, it takes time and patience to do it, but I did get it with no bubbles on there. So I'm going to go ahead and put this back into the frame and get this LCD back together pretty much. So that was the LCD somewhat assembled. I still gotta wait for the lamp to come in, and then I'll get the lamp assembly in, and hopefully it shall work. So went ahead and installed the LCD assembly back into the scope temporary. I still have to wait for the lamp assembly to get the backlight working and stuff like that, but I figure I'll go and test the LCD because that should still work at least. You're not gonna get no backlight, so of course. But yep, she is good, it looks like. And yes, it does work. Let's go and clear and see if we get a trace, and yes, the LCD is fully working now. Once I get the backlight in, then we'll have backlight and it'll be back to normal again, but it is looking good now. So finally, the replacement cold cathode tube came in. It did take a little while. It was well packed too. I gotta admit, this company did a really good job because they had it packed in this tube and also a lot of padding around in a really oversized box. So good attention to detail. They want to make sure that thing did not come crack, and they weren't playing around. So one thing you want to do when you're replacing these tubes is definitely to measure the size. You gotta measure the lengthwise and also the diameter so you can make sure it fits in there pretty much. So I did that, and I found one close enough. It's off by maybe a millimeter or so, but it's not going to be enough to make a difference. And also, too, you want to make sure the current draw and all that, too, which I did. So next thing I'm going to go and do is remove these boots right here, these rubber protected boots, desolder these oldies. I'm going to reuse the shielded cable, of course, and then resolder them to the new tube, and then install the new tube on the LCD and hope that she does work. As you can see, disaster struck. I ordered a 90mm one because that was at the time the only one I could find. That was because when I originally measured it, I measured it about 88. Well, it turns out I kind of measured it wrong. It's actually 86mm from glass to glass and stuff like that. And also the thickness is 2.6mm. So I went ahead and made sure I double checked the measurements this time. And sure enough, I was able to actually find the exact replacement, and thankfully I found them in pairs, so he's sending two over, so I'll get the right tube in. But this was completely my fault. I'm a complete idiot. I should have double measured it, but I figure a millimeter or two off would fit in there, and I tried to squeeze it in there, and of course it snapped. But hopefully we'll be able to get this project done soon. Still working on it, as you can see. Kind of just screwed up, so hopefully in a week I'll have a new set of tubes in there. Actually, it's only going to be one, and one will be kept as a spare. But either way it goes, get it installed, and hopefully I'll get this project over with already. So I went ahead and found the tube that would fit on the side there, no problem. So I went ahead and put it in. And this here is the old burnt out one. So now I got the new one in there. And of course I went ahead and changed both polarizers on LCD because this LCD was in very bad shape. Shocked it actually survived, but here you go. We'll go and power it on and show you the results. So much better now. Now I can actually read and it's usable now. And you can see there it says THS710A. I'm going to go and modify that, of course. It's going to be a 720 after I get done with it. But you can see there, easily to read, no problem now. So yep, I consider this repair a success, and I'm gonna go ahead and modify to change the model number, put this thing back together, and call it a day with it. So for those that want to go ahead and modify the 710 to a 720A, or if you got a newer one, P, and to pretty much get more bandwidth, you go ahead and take out R213, and then you take out R207, Once you remove that, I got them. Let me see if I can see them. Well, they're there, but you can see they're right there. You can remove those. And then in this case here, I put it in R205, and I'm removing that one right now. Then I'm going to go and clean up the flux and all that on there. And this should be a 720A pretty much. So went ahead and cleaned the pads, as you can see there. Now it's pretty much nice and clean. And as you can see there, went ahead and completely removed R204. So now it's ready to go back together, and we'll see what model comes up. So went ahead and finished reassembling this Tektronix THS710A handheld oscilloscope. It should be a THS720A now. But as you can see, let's go and turn it on. Let's see what comes up. Yeah, so it's kind of scratched up. But it is what it is. This whole entire instrument's not in the best condition. And you can see there, let me go and turn this off because the glare. It says THS720A, so yep, it was a success. I'll go and get this a little bit better cleaned up, and then we'll go ahead and put some signal to it and see if it actually works. So fully reassembled this Tektronix THS710A, which is now effectively a THS720A, and it's increased in bandwidth, so now it's 100 megahertz, and also now 500 megasamples a second instead of the 250. I also went ahead and repaired the LCD on this thing. I changed both polarizers and stuff, which was a nightmare. And also repaired the backlight. And you can see here, it still looks in pretty rough condition because this thing was ran hard and put away wet, but it's definitely now usable. In person, the screen's much clearer. I mean, it's crystal clear in person. It's just because the glare and stuff like that, and also the scratches and stuff don't help. But either way it goes, we're going to go and put a signal through it, and I'll show you that it functions. And let's go ahead and do, because it timed out. It's on battery right now. Okay, so we got a 1 megahertz signal and about 1 volt peak to peak, and that's what the generator is putting out. And you can see there, very nice, no DC offset or anything like that, and it's reading pretty much dead on. Now if I go to square wave, that's a 1 megahertz square wave, and it looks perfect. We'll go and do ramp, and we'll go back to sine wave again. Actually go back to sine wave, and then we'll go ahead and increase the bandwidth on this thing. So let's do 10 megahertz. Okay, let me go to, hold on 1 minute, 10 megahertz, and we'll see how that looks. All right, and we'll go to mag setting there. And you can see, bang on 10 megahertz, no problem there. Alright, so we're going to go ahead and go 40 megahertz, alright? And you can see there, pretty close enough, alright? And there's a 40 megahertz sine wave there. No problem with that whatsoever, okay? So now we're going to go 60 megahertz. Alright, you can see it dropped off a little bit, but not at the 3 dB, and pretty good. So yes, it did increase the bandwidth. But yep, there you go. Okay, we're going to go 80 megahertz. Yep, and there you go. It's good. So yeah, I can handle the bandwidth. We'll just go a full 100 megahertz, alright? Then yep, that's what 100 megahertz looks like on this thing, and yeah, I would say pretty good. So yes, the increased bandwidth, it's definitely doing the bandwidth now. Alright, so now we'll go back down to 1 kilohertz. Okay, we'll do this here, and we'll go down. Okay, until we get a sine wave. We'll slow down the time base there. We'll go a slower sweep. And there you go, that's a 1 kilohertz signal, and it's back on, it's bang on pretty much. So Yep, it was a success, and then we'll go ahead and do square wave, of course, at 1 kilohertz. Actually, you know something? Let's do this here. Let's go frequency. Kind of curious to see. 10 megahertz, alright. And then let's go to speed up the bandwidth here. Okay, and then we're going to go ahead and see how it looks on the square wave. Yeah, it's doing pretty good, I gotta say. So there you go, and then we'll go back to sine wave. Yep, so the modification did work, and it is doing the increased bandwidth, so there you go. And like I said, this thing's fully functional and everything like that, even when I turn off the signal. Usually these things have a known issue with the optic couplers and stuff like that, and you'll get a DC offset on it. And there's absolutely no problem with this thing. It's just, you know, kind of scratched up, missing the backstand and the accessories and stuff like that. But it does fully functional, and that was the goal, to make this thing functional. And the repair to this Tektronix THS710A, now 720A, was a full success. So went ahead and ran the self-calibration. As you can see, it passed it. Okay, so now let's put a signal in there. And I noticed the issue with the position is now fixed. So I could do that at 10 megahertz. It was out. Put 10 megahertz there. Of course, we'll speed up the sweep. And you can see there, much better now. So yeah, she's fully operational and seems to be pretty accurate actually too. Let's just go to the measurement. Alright, and then we'll go ahead and we'll do it here. I gotta kind of see on this screen there. Alright, we'll go ahead and select, well, not select page. Okay, we'll do that again. Yep, select measurement. Alright, and then we'll change the page. And you can see there, she's bang on. So yep, this one's good to go now.